And we return. Had a phone call. So we were at the 8z minus 15 equals negative 7. Then we're going to add 15 to both sides. When we do that, now we get 8z equals z, or 8z equals 8. We use inverse operations, divide by 8, divide by 8, and we get z equals 1. Here, we must look at each side. Remember, only look at one side. Over here, I see I have a 12z. Here I have a negative 4z. That makes for 8z minus 12. On this side, like terms, I have a positive 6, a positive 32. Negative 2z plus 38. Hey, I've got the things that I need. Now I want to move variables, get all those together. So I see that 8z and 2z, I can combine those. So if I add 2z, I will get 10z minus a 12 equals 38. Now I want to get the numbers together. Inverse operation, they're subtracting 12 there, so I'm going to add it. I'm going to add 12. So 10z equals 50. And I just brought that down because 12 minus 12 is there. Divide by my 10, divide by my 10, and z equals 5. Notice how nice they're being. Lots of whole numbers as answers. That doesn't always happen, but will for the first bit here. Okay? All right, we'll show you how they do it. So the steps. Look at each separate side. Combine like terms. Then add 2z, or mess with your variables to get them all combined in one location. Then you work with your numbers to get them all combined in one location. Inverse operation, inverse operation. Then we have 10z equals 50. Inverse operation of division to undo the multiplication of 10 times z. And we get z equals 5. Now we put out word problems. Oh, fun, fun, fun. Daisy's Flowers sell a rose bouquet for $39.95 plus $2.95 for every rose. All right? A competing florist sells a similar bouquet for $26 plus $4.50 for every rose. Find the number of roses that would make both florist bouquets cost the same prices. We want to make them equal, but we got to know what to do. They were lovely and nice and big jerks and said $39.95 was this price. Plus, we're going to add $2.95 for every rose. That's how you get the total cost of their bouquet. The other company, they're like, oh, we only charge $26 for the bouquet. Oh, nice even number. We don't have to write those two decimals there. But we charge $4.50 for every rose. Do you see how this is an equation where we have a variable on each side? $2.95 times the number of roses, $4.50 times the number of roses, the standard cost. All right, when we do this, let's make sure we have that. And since there's all the decimals, I'll let them do the math. All right, so let R represent the roses. They use a lowercase, but we have the same equation. So the first thing we're going to do, I'm probably going to mess with or say move this one. Subtract the 295R. Inverse operations, we're going to get the R's together. When we do that, $39.95 equals 26, and we get 1.55 or $1.55 per rose. Then we want to get these two together, so we're going to have to subtract that 26. We subtract that 26. $13.95 equals $1.55 per rose. We'll use our inverse operations, divide both sides by 1.55. And we figure out if we get 9 roses, both shops' bouquets will end up costing the same, Since their roses cost less per rose, theirs cost more, but their setup fee is less, and their setup fee is more. So 9 roses is that magic number. All right. Marla's gift basket sells a muffin basket for $22 plus $2.25 for each balloon. So $22 to get that basket. And then $2.25 for each balloon. A competing service sells a similar muffin basket. It costs $16 only, and $3 for every balloon. They just chose to market it different. More at the start, less per balloon. Less at the start, more per balloon. Now, we want to know what number of balloons would make the baskets cost the same amount. Now, if you're really cheaping out and only getting maybe 1 or 2 balloons, you probably want to go with that one. If you're going to get a bunch of balloons, you may want to go with this one. See which one's the better deal. All right. They write it out so much better, we'll let them copy our equation. Maybe on the next one, you try to set up the equation on your own. So there's the 22 plus the 225, B, because the number of balloons. 16 plus the 3, they left the 2 zeros in there, B. We don't have to, but we can. So we're going to subtract 225. They choose to move this one because it keeps it positive. They move the one that is less. You don't have to, but I like to do it because then you're not dealing with negatives as much. So we do that. We've combined our variable numbers. Okay? Now we'll look to use inverse operations, and we'll combine. Since that's adding 16, we'll subtract 16. Subtract 16. $6 equals 75 cents per balloon. We divide by that B. And when we do so, we find that 8 balloons would be the same cost. If you buy 8 balloons and get this, it'd have the same cost as 8 balloons with this. So 8 balloons would make the purchasing cost the same. This is the one suggesting you try. Jamie spends the same amount of money each morning. On Sunday, he bought a newspaper for $1.25 and also bought 2 donuts. On Monday, he bought a newspaper for 50 cents and bought 5 donuts. And on Tuesday, he spent the same amount of money and bought just donuts. How many donuts did he buy on Tuesday? All right, so we are not ready to do Tuesday. We've got to think of that later. We should probably compare Sunday and Monday first. This is a 2-step problem. It's a doozy. Sunday, he bought a newspaper. That newspaper cost him $1.25. And he also bought 2 donuts, plus 2 donuts. We don't know the cost for those donuts, but we're going to find that out. Then on Monday, he bought a newspaper for 50 cents. I would write it as a decimal. And he bought 5 donuts. And he spent the same amount of money. All right. From there, we can figure out what the cost of each donut is. Then we could use that to figure out how much money he spent on donuts on there. And on Tuesday he spent the same amount of money and bought just donuts. So we got to find out how much money he spends each day, and we got to find out how much each donut cost. Then we'll be able to figure that out. So the first thing I suggest doing, let's find out how much each donut costs. I bet that's what they do first too. First, solve for the price of 1 donut. Hey, it's like I knew this. There's our equation. First thing we want to do is combine the variable terms. Do you think they're going to subtract the 2 or the 5? They like to keep things positive. So they'll use inverse operations. Subtract the 2d, subtract the 2d from them. Notice they go with each of these because those are like terms. You can't take 2d away from 0.5. They're not like terms. Okay? Then $1.25 equals 50 cents plus that. So now we're going to combine these. So that's positive. We're going to subtract the 50 cents from both sides. 75 cents equals 3 donuts. If we do our division, divide by 3, each donut is going to cost 25 cents. That's an important piece of information. So the donut costs 25 cents. Okay. Keep that in your memory banks. Now it's important to find out how much money he spends each day, because then we can figure out how many donuts he bought on Tuesday when he only bought donuts. Okay? So he chooses one of the original expressions. It doesn't matter which one. You could choose this one. And we put in the price of the donuts. Because when he does this, oh, it doesn't show you. He spent 50 cents on donuts and $1.25 on papers. That's $1.75. Now, if you didn't remember, the second day, he spent 50 cents on the paper, and he bought 5 donuts times 0.25. So that's $1.25, and he spends $1.75. Oh, so he spends the same money each morning. So he spends $1.75 a day. Okay, so now we want to find out how many donuts he bought if he spent $1.75 and only bought donuts. So that means we let n represent donuts. Each donut costs 25 cents. We don't know how many donuts he got. Now we're ready to do the division. Divide by 0.25. And we're going to find out that he got 7 donuts. Oh, he bought 7 donuts on Tuesday. I hope he was sharing. Okay. Multiple step problems. You have to find the part, to find the next part, to find the next part. Helen walks the same distance every day. On Tuesdays and Thursdays, she walks 2 laps on the track and then walks 4 miles. On Monday, Wednesdays, and Fridays, she walks 4 laps on the track and then walks 2 miles. On Saturdays, she just walks laps. How many laps does she walk on Saturdays? So we got to compare our Tuesday or our Thursday to a Monday, Wednesday, or Friday. So how do we do that? So she walks 2 laps. And when I use L's, I use capital one. So 2 L's. And then she walks 4 miles. Okay? And on Monday, Wednesdays, and Fridays, she walks 4 L's. And she just walks 2 miles. Now, some of you may already have got to the answer. If you did, you're math people. Congratulations. But for the rest of us, let's walk through it. First, we want to figure out for the distance around the track. By using, they used x instead of L, 2x plus 4, 4x plus 2. We can figure out what x is. And x will be that distance around the track. So the first thing we're going to do, we're going to combine the variables. They like to keep it positive, so I bet they work with 2x. All right? They subtract 2x, and they subtract 2x. Notice they go with the same items because they're like terms. So then we get 4 equals 2x plus 2. Now we're going to combine the terms that don't have variables. Inverse operations, so we'll subtract that 2. All right? So we get 2 equals 2x. Use our inverse operations and divide by 2 so the x is by itself. X equals 1. So 1 lap is 1 mile. Oh, that is helpful information. Now find the total distance Helen walks each day. Choose one of the original expressions. So they chose 2x plus 4. So you plug that 1 mile into each, and she finds out she walks 6 miles each day. So how many laps does she walk on Saturday? Well, let n represent the number of laps. So the number of laps times the 1 mile, and we want to walk 6 total miles, she walks 6 laps on Saturdays. One more of these, and then we go on. The equation t equals m plus 10e gives the test score t for a student who answers M multiple choice questions and E essay questions correctly. Solve this equation for E. Wow, there's a lot there, but it actually is solvable in one step. Locate E in the equation. What we want to do is we want to get E all by itself. Use all our inverse operations and all our tips and tricks to do that. So, we want this to be all by itself. So the first thing we probably need to do is we need to get rid of M. Well, we're adding, so if we use inverse operations, minus M. Are there any like terms for M over here on this side? There are not, but I still have to subtract M from this side. So I could look at T minus M. Since they weren't like terms, they couldn't combine them. And when M minus M, that equals 10E. I'm closer to getting E all by itself. Remember, these weren't like terms, so we just have to write them out as they're both on that side. 10 times E. Well, how do I undo multiplication? I use my division skills. Divide the entire side by 10. Oh. E equals T minus M divided by 10. Let's see if we did it correctly. Since M is added to T, subtract it from both sides. Hey, so far we're doing okay. Then, since E is multiplied by 10, divide 10 from both sides. And we get E equals 10T minus M over 10. Oh. We don't always have to have a number as an answer. Okay? The formula for an object's final velocity is F equals I minus G over T. We have done this some in science. And that's why we do that I equals M times V. Oh, and we can solve for any part of it. We're doing the same thing. Where I is the object's initial velocity, G is acceleration due to gravity, and T is time. Solve for I. That means we want I all by itself. So let's rewrite the equation. There's I. We want that to be all by its lonesome. Well, we've added GT, or we subtracted GT from that. So to get it to move to the other side, we add GT. If we do that to one side, we must do it to the other side. Those are not like terms, so we're just going to write it as F plus GT. And that's going to equal I. Hold it! I don't need to go any further. I have it in I terms. That is my answer. When you get that variable all by itself with no number next to it, you have your answer. Let's make sure. Since GT is subtracted from I, we want to add GT to both sides. Not like terms, so we can't combine them, so we just have F plus GT, and that equals I. This seems kind of nonsensical, but it will help. All right, guys, it's in 2 segments because it were so long. Bye-bye.